So today our topic is about chemical bonding, and here is the definition of the chemical bonding. Actually, this is the interaction that account for the association of atoms into the molecules. Like in case of the water molecules, there are two hydrogen and one oxygen. Let's suppose this is the carbon dioxide, and there is one carbon and two oxygens are there. So how they are bonded to each other, and the way of interaction between the atoms which can hold them to form a molecule, that is actually called the chemical bonding. So this is the simple definition of the chemical bonding. And what is there are different types, and it may be the ionic bond, or it may be a covalent, and covalent in terms of the polar bond, and covalent in terms of the non-polar bond. So I will actually explain in detail in the next slides. So the bond, we have divided this chemical bond into the two. One is the ionic bond and the other one is the covalent bond. So let us start with what is the ionic bond. Ionic bond is if the molecule is having the ions. Ions mean there are two ions. One is the negatively charged ion and other one is the positively charged ion. Then this type of the bond is called the ionic bond. So you will clearly see what are the difference the bonds over here. And these are the in case of the sodium and the chloride, and it is the with the interaction between the positive ion and the negative ion, we call it, this is the electrostatic interaction between the plus and the negative ion, and that bond is called the ionic bond. And in case of the uh, uh, covalent bond are when there are no permanent charges are there, and that means this is the, we call it the partially positive charge and partially negative charge. And then this type of the bond is called the covalent bond, and it results from the sharing of the one electron from each of the atom. One electron is sharing from the hydrogen and one electron is sharing by the chlorine, and this bond is formed by the sharing of the one electron, and that is called the covalent bond. But here the atoms are non-equivalent. That means there are both different atoms are present over here. One is the hydrogen and one is the chlorine. That's why the the interaction of all atoms with the electrons is different. And in the previous lecture we have studied that this is called the electron negativity. That means the attraction of the, or the pulling of the electron towards one of the atom, and that is called the electronegative atom. That's why the chlorine is having the minus charge, and there is the deficiency over the hydrogen atom, and that's why this is having the positive charge. So this is the polar covalent bond. And there are another covalent bond that is called the non-polar covalent bond, and both are the covalent bond. And because all these two bonds, the bond is formed by the sharing of electron from each of the atom, and one electron is shared by the chlorine and one electron is shared by the another chlorine. So one bond is formed over here, and that's why this is called the covalent bond. And why it is called the non-polar bond? Because there are no partially positive and the partially negative charges are over here. Because chlorine, there are the chlorine atoms, and both are having the same electronegativity as we have discussed before. And when there is the same electronegativity, the bond should be non-polar in nature because of not having the negative and the positive charges. Let's see the detail over here. This is the uh, example of the criteria So this is the criteria to identify the covalent bond and the ionic bond. And very simple criteria. These values are given in the literature, or maybe I will give you the values, and these are also mentioned in the periodic table. And En is the electron activity. So how can you identify whether the bonds between the atoms in a molecule is covalent bond or a ionic bond? And the criteria is you have to calculate the total electron activity. Let's suppose in this case the electron activity for the chlorine is 3 and for the carbon is 2.5, and the difference in electron activity 3 minus 2.5 is zero point 0.5. And here, in case of the sodium chloride, and electron activity of the chlorine again is 3 and the sodium is 0.9, and 3 minus zero point 0.9 is 2.1. So you can clearly see over here there is the large difference between the electron activity of the two molecules. One is the HCl4 and other one is the NaCl. So if now I am going to tell you what is the rule over here. If the electron activity difference is less than 2, then there is a possibility of the covalent bond. And if the electron activity is greater than 2, then there is a possibility of the ionic bond. So this is the very simple and one-step criteria to identify between the molecules which one is having the covalent bond and which one is having the ionic bond. It is just to calculate the difference in electron activity of all the atoms present in the molecule, and by comparing the electron activity with the two, and we have set the criteria with the two. If less than 2, then it is the uh, uh, covalent bond, and if it is more than 2, then of course it would be a ionic bond. And we have divided this covalent bond into the two. One is the polar bond and one is the non-polar bond. So if it is the polar bond, then you must see a difference greater than 0. And if it is the non-polar covalent bond, then this difference should be equal to 0, because all the atoms in a molecules are same. Like we have seen the one of the example is chlorine gas, and it is formed by the Cl atoms. And when you just take a difference between 3 minus 3, it will be equal to 0. So this is the criteria to judge whether your uh, covalent bond is polar or the non-polar. If it is 0, then it should be non-polar, and if it is greater than 0 but less than 2, then it should be a polar covalent bond. So now we are going to further, now we are going to study the detail of the ionic bond. How can you show the bonds between the different ions present in a molecule? So this is the first rule. That means ionic bonding is a complete transfer of electrons between the atoms. So ions are only formed when there is the transfer of the electrons, and the covalent bond is the sharing of the electrons. So there is the difference. So when electrons are transferred from one atom to another atom, then there is the formation or creation of the charge on the atoms. I will show you the with the example later on. So it is the type of the chemical bond that generates two oppositely charged ions. That means it must be one atom is having a positive charge and other one is having the negative charge. So first rule is the transfer of electron, and with the transfer of electron, the two charges are formed, and one is the positive charge, another one is the negative charge. Third one is the ionic bonds. Actually, there is the general criteria. Uh, Generally, the metal loses the electron, become positively charged ion, because if they lose the electron and then they become electron deficient, that's why they become a positively charged cations. And in the other way, the non-metals accept the electrons and they will become negatively charged ions, because any atom when accept the electron, because the electron is having the negative charge, so they will become electronegative. So that means they are having the anion, and the metals are having the cations. So ionic bond require an electron donor, often a metal, that an electron acceptor, a non-metal. Of course, when the metals loses the electron, that means it is called the electron donor. So the other one, the non-metals are going to accept the electron. That's why they are called the electron acceptor, and they are usually non-metal. That is given over here, because they always maintain the and they want to move towards the noble gases. And noble gases we have earlier studied, these are indicated with the this pink color, dark pink color over here. This is the 8A group, and these are the metals, and all these are over here in the, let's suppose, in the seventh group. These are the non-metals, so they are going to accept the electron, and the metals usually are going to donate the electron. So that's why the metals are the electron donor, and the non-metals usually are called the electron acceptor. So this is the actually the criteria and the general rules for the formation of the ionic bond. And this is very important rule. We call it the octet rule, and octa mean 8. So this is having to follow the octet rule. And what is the octet rule? It is the ionic bond is observed because the metals have few electrons in their outermost shells, and by losing those electrons, these metal can achieve the noble gases configuration and satisfy the octet rule. So in simply, octet rule mean they must have 8 electrons in their outermost shell. So if you look at the 8th A group, so all the noble gases are having the eighth present in the 8th A group must have the 8 electrons in their outer shell, and that's why they follow the octet rule. So you must consider only the valence shell, not the other shells. The valence shell means the outer shell is called the valence shell, and there must be 8 electrons, and this is called the octet rule. Let's go. What is happening over here with the metals are here. Let's suppose this is the first one is the hydrogen, second one is the helium, third one is the lithium. So when the lithium lose the 1 electrons, and it will move towards the helium, and helium is the noble gas. So there is one exception over here, because this is not following the octet rule. We call it, no, it has the closed shelled configuration, because there are only maximum 2 electrons they can retain the elements present in the first period, hydrogen and the helium. But the reason is same, because when the electron is removed from the helium, it will move to the when the electron is removed from the lithium, it will move to the helium configuration. This we are just only discussing the electronic configuration. That means the electrons present in the outer shell, not the protons and the neutrons, because all elements are identical towards the number of protons are present in the nucleus. So what about the non-metals? Non-metals are here. Let's suppose this is the fluorine in the seventh, and when it accepts the electron, it will having the same configuration as the neon is having in the 8th A group, and neon is the noble gas. So the nutshell of this discussion is the atoms present in the first day or the second day, all the metals, when they lose the electron, they achieve the noble gases configuration. And when the non-metals accept the electron, they also achieve the noble gas configuration. And noble gas electronic configuration is all are having the eighth electron in their outermost shell. And this is all about the ionic bond. Let's do some of the example, starting with very simple one, and this is the formation of sodium chloride. And as we have checked earlier, the difference between the electron activity between the sodium and the chloride is more than 2. That's why it formed the ionic bond. So let's start with the basic. This is the atom of the sodium, and sodium is having the 11 atomic number. That means 11 protons are there and 11 electron are there. And first you have to write down the electronic configuration as we have studied in the previous lecture. So 11th electron, first there is the filling of the electron. You can do like this, and I suggest to watch again that video. So because if you do not know the electronic configuration, then it will be difficult to understand the formation of all these bonds, because all lecture is linked with the other lecture. So I am just repeating this one. 11th electron are there. So first is 1s2 is filled with the 2 electron, 2s2 is filled, and there is 2p6 because p is maximum having the 6 electrons. Or you may further split into the 3 orbital that we discussed are the px, py, and pz, and each p is having 2 electron. That's why p is having the 6 electron. And then this is the 6, 7, 8, 9, 10, and then the 11th electron will move to the third s orbital. And if you see over here, first 1s, 2p, 2s, and then this is the 1s, 2s, 2p, and 3s. And the same, the way is written over here. The 11th electron is moving over here. That means this is having 1 electron is present in the outer shell. And this is the way you can also see over here. This is the first shell. First shell is 1s2 only, and it is having the 2 electrons. And in the second shell, because this is the principal quantum number, or the shell is indicating, this number is indicating the shell or the principal quantum number. And this is the two shell, or the second shell is having the 6 plus 2, 8 electrons. And these are over here, 1, 2, 3, 4, 5, 6, 7, and 8. So 8 electrons are there. And now with the third shell, because this is the third shell, and because the principal quantum number over here is 3, and it is having only 1 electron, and 1 electron is there. So there are 8 protons, 8 electrons are there. It is not having any charge. When this electron is removed out of the sodium, and then it will become electropositive, because it is having the deficiency of one of the electron. So that's why it is having the +1 charge. If it remove 2 electrons, then there is the possibility of having the 2 positive charges, but not in case of the sodium. It may be the case of the other metals are present. So this we have discussed in the previous slide. So why the sodium is going to lose 1 electron, and that is called the octet rule, because when it remove 1 electron out of its outer shell, now the outer shell in this case is the this third shell, and third shell is having 1 electron, and when 1 electron is removed, and now this is the second shell is called the valence shell. And in this valence shell, or the outermost shell, there are the 8 electrons are present. Now this is called the octet rule. It has achieved the octet rule, and because this sodium is having the configuration, electronic configuration similar to the noble gas configuration, that's why this is the formation of the sodium plus sign. And this is the electronic configuration is written over here. When sodium is losing one of the electron. So you must remove one electron from the third shell as indicated over here, and then remaining electronic configuration would be 1s2, 2s2, 2p6, and there is the 8 electron present in the outermost shell. So that means it is following the octet rule. Now, the second is the chlorine, and chlorine is having the 17 atomic number. That means 17 protons are there, 17 electrons are there, and there is no charge over here because protons are equal to the electrons. And similarly, you can fill the electronic configuration. This is the first S, 2s, then 2p, 3s, and then 3p. So it is ending with the 3p. This is the first shell. First shell is 1s2, so it is having 2 electrons. And in the second shell, it is having 8 electrons, so 8 electrons are present over here. And in the third shell, it is having the 7th electron, and 7 electrons are over here. So if this chlorine atom is achieving the noble gases configuration, it must receive one of the electron. So when it receive one electron, then it will become electronegative, because now there are 17 proton, 17 plus and 18 electron, that means 18 minus. So one net charge would be -1 on the chlorine, and it is indicated over here. So that means what is the octet rule over here? Because there is the deficiency of one electron in the outermost shell. So this is coming from the sodium, and it will become electronegative, and the sodium will become electropositive. And this is the electronic configuration in case of the Cl minus. And here you can see the difference. There are the in the outermost shell or the third shell, there are the seventh electron, and here are the 8 electrons are present. That means this chlorine has also satisfied the octet rule and has achieved the noble gas configuration. And in this way you can make a bond between any of the atoms present in a molecule by using this display. And one way is the to write down in a shells the electron, count the total number of electron, proton, and then write down the electronic configuration of the neutral atom and for the ionic in a similar way. And there is the final chemical bond between the sodium and the chlorine. This 8 electrons in the outermost shell, and also 8 electrons from the outermost shell. So this is the one electron is coming from the valence electrons present in the the electron present in the valence shell of the sodium atom. So it is indicated over here. One it is on, and one is coming from the sodium atom. And the electronic configuration is written over here. In the valence shell, both are having the 8 electrons. And this is another way. One electron is moved to the chlorine. That's why it will become electropositive, and chlorine becomes electronegative after receiving the electron, and this is electropositive after donating the electron. And this is the final way to represent the ionic bond between the sodium and the chlorine. So this is the one example I have given to you in detail, and in a similar way you can do any of the examples. I am going to do some of the examples right now, and you will find the other one in your assignment. So this is the detail. You have to do the detail of all the chemical bonds formation in case of the ionic bond. So you have to start from the circular path, filling the electron in the shells, and then you have to write down the electronic configuration, and then with the movement of the or the displace of the one of the electron or from the metals to the non-metal, and they have become electropositive and the negative. That's why the bond between the positive and the negative are the ionic bond. So this is another example, and other example is the lithium fluoride ionic bond. No, I'm just giving you in brief, and you can do the same exercise at home as I have explained in case of the sodium chloride. So for the lithium fluoride, lithium is having 3 atomic number. That's why the electronic configuration is written over here. 3 electrons are there, 1s2 and 2s1. And fluorine is having the is present in the seventh A group, and 5, 6, 7, 8, 9. 9 is the atomic number of fluorine, having 9 proton and of course 9 electrons. And this is called the open shell configuration. That means whatever the electrons are present in the outermost shells, that's why this is called the open shell configuration. And why it is closed? No, this is the formation of the bond. 1 electron is present in the outermost shell of the lithium, and 1 electron is required for the fluorine to complete its octet 6, 7, 8. And because the previously there was 7 electron, and after the receipt of 1 electron from the lithium, it has achieved the electronic configuration of the noble gases or has completed its octet. Now that's why no further possibility is no more is there, because the outermost shell of the fluorine is full and the lithium is only having the outermost shell. The 2 electrons the lithium is having only 2 electrons in its outermost shell. So that's why it is called the closed shell configuration. And it is shown over here. 1 electron was there in the lithium moving to the fluorine. Octet is complete and there is only possibility of the 2 electron. That means this is lithium has also achieved its the outermost configuration, and that is the formation of the ionic bond. It is going to receive one of the electron, that's why it become electronegative, and similarly the rest of the atom become electropositive, who is going to donate the electron. This is the ionic bond formation between lithium and the fluorine. Another example is the magnesium fluoride. And now there are the, if you write down the electronic configuration, you will find there are the 2 electrons are present in the outermost shell of the magnesium. And this is a similar case we have discussed in case of the sodium chloride. And this is the chlorine belongs to the seventh A group, having the 7 electron in the outermost shell, and it needs 1 electron. That's why, and another chlorine atom also needs 1 electron, and the 2 electrons are present in the magnesium shell. And when they this magnesium moves its 1 electron to each of the chlorine atoms. So these both atoms become electronegative, 1 electron, because they are receiving 1 electron, but magnesium becomes electropositive with 2 plus ion, because uh, magnesium donates 2 electrons to each of the chlorine atoms. That's why it becomes electropositive and is having the plus 2 ions. And this is the example what is written over here in the dot structure. Similar to this one, there is no any difference between these two examples, but it is clearly written over here how they are going to form the bond, and it is also indicated over here. So this is all about the our ionic bond formation. Because the time, I am just ending this video because due to the limited time duration. So I'm just showing you two of the more example. This is a magnesium sulfide. It is having 2 electrons are present in the outermost shell, and this sulfurs required 2 electrons. That's why 2 electrons are shifted from the magnesium and it become electropositive 2 plus, and 2 electrons are received. That's why it will become electronegative with the 2 minus sign. Similarly, with the magnesium oxide, again, one magnesium is having 2 electrons in the outermost shell, and this is the having the 6 electron oxygen. 2 electrons are required. 2 electrons move to the oxygen. That's why it will become electropositive 2, and it will become electronegative -2. And this is the ionic bond between the magnesium oxide. And this is the last example, calcium chloride. Each chlorine requires 1 electron, and the 2 electrons are present in the outermost shell of the calcium. And when it donates the electron to each of the chlorine atoms, octet of each of the chlorine is complete, having 8 electron in the outermost shell, and the calcium is having also 8 electron in the outermost shell. So octet of all the atoms present in this ionic molecule is complete, and that is the formation of the ionic bond between the calcium chloride. So with this